We're going to look at a binomial probability formula. This formula is going to enable us to answer probability questions that cannot be answered with a tree diagram. For example, tossing the coin 10 times had too many outcomes, 1024, too many outcomes to be able to actually weed through and figure out the probability. So for a binomial experiment, the probability of getting S successes, that's S meaning S is going to represent a number of successes, in N trials is computed using the binomial probability formula. And here's our formula. Okay. We have N CS times P raised to the S power times Q raised to the N minus S power. The meanings of these symbols: N is the number of independent trials, S is the number of successes, N minus S is the number of failures. Let's just think about why that makes sense. If N is the number of independent trials, let's say you flip a coin 15 times, and S, the number of successes, is denoted as 5, getting 5 heads. The number of failures would therefore be 10 minus 5, or 10. That's how many tails you would get. Okay, so if there are 5 heads, there would be 10 that would come out as tails. NCS is a mathematical notation for a combination, and what it gives us is the number of ways S successes can occur in N trials. We are going to bypass this formula. We're going to use our calculator on the TI-84. P represents the probability of success for one trial, and Q represents the probability of failure for one trial, which is 1 minus P. So imagine that we're rolling a die. The probability of success could be the probability of getting a 6. That's 1 over 6. The probability of getting of not getting a 6, that would be considered the failure, would be Q. 1 minus 1 over 6, which is 5 over 6. Anything that's not a 6, 5 over 6. The textbook does go through the formula manually. You can look at the textbook and trace through the problems that use this formula and do it by hand. An alternative to using the binomial probability formula is to use the built-in function of the TI-84 calculator. It's called Binom PDF. It stands for Binomial Probability Distribution Function. And the way we find it is we go to our calculator, we press the second key, and we go to the vars key, which is to the left of clear. Above vars in blue letters it says DISTR. That stands for distribution. So we click that. We're going to scroll down to A. The other way that you can get to A is by scrolling up and around to the bottom. Okay, there it is. Now notice that A and B look pretty similar, but there's a big difference. You're always going to be choosing Binom PDF, which is option A. It's very easy to mistake option B and option A, so make sure that you always are very careful to choose the correct one. Okay, with A highlighted, you hit enter, and it brings up a screen where you can enter 3 items: the number of trials, P stands for the probability of success on a single trial, and X value stands for the number of successes. Now that we were symbolizing this in the formula with the letters N, P, and S. Here it's verbally described as trials, P, and X value. They are the same thing. So you're going to enter numbers in each of these, and then you'll hit paste, and it will go to your home screen, and then you can see the probability. Now, like all probability questions, we're expecting a number between 0 and 1. So let's look at an example. Every time you read a probability question involving binomial probability, you want to identify 3 items: n, the number of trials; p, the probability of success on a single trial; and s, the number of successes. Okay, the first question we're going to look at: determine the probability of getting 3 successes in 4 trials if p is 2/3. Round your answer to 4 decimal places. Okay, this is probably very simplistic, and you won't see anything this simple on a test or homework assignment because the values are basically being given to you. If you read the problem, you're trying to find the probability of getting 3 successes. That means the s part of the equation is 3. Then you keep reading and it says in 4 trials, which means that the n part of the equation is 4. If p equals 2/3, and it's giving you p as 2/3. Now p can be entered into the calculator as 2/3, which we're going to do because this is how it's provided to us in this problem. You could also enter it as a decimal. Okay, so let's go to the calculator and enter s is 3, n is 4, and p is 2/3. Okay, so trials, 4 trials. We're not told what the trials are. We don't know if they're flips of a coin or rolls of a die. We have no idea. We're told though, so we use our arrow down button to get to the next row. We're told that p is 2/3. So to enter 2/3 as a fraction, we do 2 divide by 3, 2/3. We go down. X value, which is s, the number of successes, 3. So let's try to understand exactly what we're looking for in this question. We are doing something 4 times. We want to know the probability of succeeding on 3 of those 4 times if the probability of succeeding on 1 trial is 2/3. Because of the relationship between the number of trials and the number of successes, s, or x value, can never be more than the number of trials. Okay, it should make sense to you. You do something 4 times, you want to know the probability of succeeding 3 of those 4 times, or 2 of those 4 times, or 1 of those 4 times, or 4 of those 4 times, but it would never make sense to succeed 5 times if you're only doing the trial 4 times. So after the 3 numbers are entered, you're going to go down to paste, hit enter, and enter that on your home screen. Press enter again. Okay, here's your answer, 0.3951, because we're going to round to 4 decimal places. So since that's a 6, we're going to bring the 0 up to a 1, 0.3951. As a decimal, also it could be expressed as a percent, 39.51%. Okay, so that's exactly what we have here. 4 2/3 3. We hit enter, 0.3951, 39.51%. Okay, now you will be told specifically on web work or a test whether or not you should express your answer as a decimal or a percent. As a decimal, most of the time you're going to be asked to express the probability to 4 decimal places, and as a percent, most of the time you will be asked to express it to 2 decimal places. Okay, let's look at a